Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 4, Lesson number 2 on rational exponents. Now, this is a topic that is definitely unique and new to Common Core Algebra 2. Perhaps you had some teachers that maybe touched on it in Common Core Algebra 1. I doubt so much geometry. But today, we're essentially going to be looking at what it means to have a fractional exponent. What does it mean to raise a number to the 1/3 or the 2/5 or the 1/2? So we're going to be diving into that today. It's a little bit of a confusing topic, but hopefully our exponent work so far has set us up for it. Let's jump right into it. Rational or fractional exponents, right? I mean, we all know that 5 to the third means 5 times 5 times 5. 5 to the 0 equals 1. Maybe I'm not totally comfortable with that, but at least I've used it enough that I'm kind of aware of it. And 5 to the negative 3, well, that means dividing 1 by 5 3 times, or dividing 1 by 5 to the third. But again, today what we're going to be dealing with is something like that. What does it mean to have 5 to the 1/3? Does that mean multiply by 5 1/3 times? Well, I don't really know what that even means. So let's jump into it. Now, strangely enough, what we're going to need more than anything else is the exponent property from the last lesson, the product property of exponents. Okay? Now, in this problem, it says, use that property to rewrite each of the following as a simplified exponential expression. There is no need to find a final numerical value. All right? So, try these out. Pause the video. After the last lesson, you should be able to do all 4 of these rather quickly. Go ahead. All right. Well, if you recall from our last lesson, when we have a base raised to a power raised to another power, we simply multiply the 2 powers together. So 2 to the third to the fourth is 2 to the 3 times 4, which is 2 to the 12. Now that is some number, but it's rather large, and we're not gonna worry about it. 5 to the negative 2 to the fifth. Remember this. We extended this to negative exponents as well. Would be 5 to the negative 2 times 5, or 5 to the negative 10. 3 to the 7th to the 0, well, that's going to be 3 to the 7 times 0, which is going to be 3 to the 0. Or if you couldn't help yourself and you wrote down the number 1, that's great too. Now this one looks horrible, but keep in mind we could always sort of work our way out, right? 4 to the 2nd to the negative 2 would be 4 to the negative 4. And then we would have 4 to the negative 8. All right. So I just wanted to review that law because strangely enough, that is going to be how we are going to try to first understand fractional exponents. Anyhow, pause the video now if you need to, and then we'll move on and start to tackle these things. All right, let's do it. Fractional exponents, here we come. All right, so we're going to start with the easiest fraction, the one that you learned first, a fraction of 1/2. And we're going to ask ourselves, what does it mean to have 16 to the 1/2? It certainly doesn't mean that we have the number 8. That would be 16 times 1/2. But let's take a look at letter A. It says, apply the product property to simplify 16 to the 1/2 squared. Then it says, what other number squared yields 16? So think about this for a second. If we have 16 to the 1/2 squared, then that property that we just had said that it should be 16 to the 1/2 times 2, which is 16 to the first, and that's just 16. All right, so what, right? Well, so what is that this follow-up question, what other number squared yields 16? So what other number when we square it equals 16, right? Because, I mean, that's what we're doing here. We're taking a number, we're squaring it, and we're getting 16. Well, 4 squared is also 16. So that means that 16 to the 1/2 must be 4. 16 to the 1/2 must be 4. Oh, but that means that 16 to the 1/2 Must be the square root of 16. There it is, right? And there we have it. Fractional exponents are roots. Fractional exponents are roots. Isn't that cool? Specifically, the 1/2 power is the square root. All right, we're going to extend this to cubed roots and fourth roots and things like that. But isn't that cool? A power of 1/2 just indicates a square root. That's a lot to absorb. So what I want you to do is pause the video right now and think about this a bit. If it seems strange and you're not really quite comfortable with it, don't worry about it. We'll get more comfortable as the lesson moves on. So pause the video now. All right, let me clear out the text. Then let's try to reinforce this. Test the equivalence of the 1/2 exponent to the square root by using your calculator to evaluate each of the following. Be careful how you enter each expression. All right, well, it's been a little bit since we've opened up the TI-84 Plus, but let's do it right now. All right, there's my TI-84 Plus. Awesome. Okay, so all I really want to do is just some button pushing on here. Nothing fancy. I'm not graphing equations or anything like this. I just want to look at 25 to the 1/2 and see whether it's really equal to the square root of 25, right? Is this really the case? So let's do it. Let's type in 25. Then let's use that caret button right here. Do that to the 1/2. Now, my calculator and many of yours have kind of a modern operating system. But you do have to watch out because on some calculators, you absolutely positively must enter it like this, with that 1/2 in parentheses. On my calculator, I don't have to do that. In fact, all I have to do now, since I have 25 to the 1/2, is hit enter. So let me do that. And take a look. Look at that, we get 5, which is obviously the square root of 25. Okay, notice we're not getting a -5 as well because 25 to the 1/2 is by definition the positive square root of 25, the positive square root. All right. Now I've picked perfect squares here, 81 and 100. Why don't you on your calculator verify that those also give you square roots? Pause the video now. All right. Well, hey, let's do them both real quick. All right, let me type in 81, caret button, 1/2, enter. There we go. We get 9, right? Which is the square root of 81. Let's try 100. Let's do 100 raised to the 1/2 equals, there it is again. I love fractional exponents. They're so cool because they indicate roots. Fractional exponents indicate roots. All right. I don't think we're going to need the TI-84 for the rest of this lesson, but you may want to keep your own calculator handy in order to do numerical work. Okay? So keep your calculator handy, but I'm going to put mine away now. All right. I'm also going to clear out the screen now, so pause the video if you need to. Kind of doubt you will, but pause it if you have to. All right, let's clear it out. So let's summarize. Make sure that we really have this. Unit fraction exponents. For n given as a positive integer, b to the 1 over n is simply its nth root. Now all we've done is worked with square roots so far, but pretty soon we'll be working with cubed roots and other ones as well. All right? But that's the key. So if I have a number to the 1/3, that's the third root. A number to the 1/4, that's the fourth root. A number to the 1/5, the fifth root. I think I'll stop there. You probably get the picture. Let's work with it a little bit more. All right, it says rewrite each of the following using roots instead of fractional exponents. Then, if necessary, evaluate using your calculator to guess and check to find the roots. Don't use the generic root function. Check with your calculator. All right, so in other words, 125 to the 1/3 is the same as the third root of 125. Now, of course, what we're looking for is the number that we multiply by itself 3 times to get 25, and that happens to be 5. 16 to the 1/4, that happens to be the 4th root of 16. Again, we're looking for a number when we multiply it by itself 4 times gives us 16, and that's 2. Now in letter C and letter D, we have negative exponents, and there are no negative roots. I mean, you can have a negative square root of 9, it's not that. But no, here we're just going to combine both the idea of a negative exponent being division, and then a fractional exponent being a root, to end up with an answer of 1/3. So we get rid of the negative by placing it in the denominator, and then we get rid of the fractional exponent by placing it under a root. So same thing here, 32 to the negative 1/5 would be equal to 1 over 32 to the 1/5, which would be 1 over the 5th root of 32. 5th root of 32 is 2, so that's 1/2. All right. So fractional exponents, when we have what's known as a unit fraction, 1/8, 1/9, 1/2, negative 1/4, etc. Those indicate pretty simple roots. But now it boils down to a really fascinating question. What would it mean to have something like this? 8 to the 3/2. What does that mean exactly? So that's what we're going to explore in the next exercise. Pause the video now and write down anything you have to before we move on. All right, we're doing it. Cleared and moving on. Okay, let's take a look at 4 to the 3/2. So now we're going to deal with a fractional exponent that isn't just 1/2, 1/3, 1/4, 1/5. We've got 3/2. Letter A, fill in the missing blank and then evaluate this expression. So 4 to the 3/2 is equal to something to the 1/2. I'll never forget this basic exponent property. If I've got x to the a to the b, I get x to the a times b. But keep in mind that 3/2 is equal to 3 times 1/2, and it's also equal to 1/2 times 3. So 4 to the 3/2 would be the same as 4 to the 3rd to the 1/2. But then 4 to the 3rd is 4 times 4, which is 16, times 4 is 64. So I'd have 64 to the 1/2, which would be the square root of 64, based on what we just did, which would be 8. Or, well, we could look at it the other way. We could say 4 to the 3/2 is the same as 4 to the 1/2 to the 3rd. Well, 4 to the 1/2 is the square root of 4, which is 2, and then 2 to the 3rd is 8. All right, so it's pretty easy, right? When we have something like 4 to the 3/2, we've got two pieces. We've got the numerator and we've got the denominator. This really represents the power, and this represents the root. And the cool thing is we can do them in either order. So what I'd like you to do, I'm not going to break out the TI-84 Plus right now, but I'd like you to verify on your calculator that 4 to the 3/2 is equal to 8. Take a moment to do that. All right, great. Well, I hope it worked out all well for you. Letter D says evaluate 27 to the 2/3 without your calculator. Show your thinking and then verify with your calculator. So go ahead and do this. Pause the video now and try to figure out what 27 to the 2/3 is without your calculator. This could be a little challenging. All right, let me explain why I said this could be a little bit challenging. You see, when you're doing 27 to the 2/3, you have to decide. Are you going to do the power first, or are you going to do the root first? Are you going to look at it as 27 squared to the 1/3, or are you going to look at it as 27 to the 1/3 squared? Well, this is much more challenging without a calculator. Number one, what's 27 squared, right? I have to think about that pretty tough. And then I'd have to take the cubed root. Ooh, I don't want to do that. This is going to be the much easier one without a calculator because we're doing the cubed root of 27 and then we're squaring it. So the cubed root of 27 is 3, then we square and we get 9. Hopefully you verified that on your calculator. If not, pause the video now, take in everything we've got, and check that one on your calculator. All right, let's clear out the screen, summarize, and then we'll finish up the lesson. Rational exponent connection to roots. For the rational number m divided by n, we define b to the m divided by n to be the nth root of b to the m, or to be the nth root of b raised to the m. So in other words, if I have 5 to the 2/5, I can think about this as the 5th root of 5 squared, or I can think of it as 5 squared, and then I've got the 5th root, right? Either way, if I have 3 to the 2/7, I can either think about that as the 7th root of 3 that I then square, or I can think of that as 3 squared, and then I take the 7th root, right? That's it. That's the whole deal with fractional exponents. They simply allow us to express a root, square root, cube root, 4th root, etc., as an exponent, and vice versa. All right, copy down what you need to, and then we'll finish up the lesson. All right, here we go. Oh, we've got one more exercise. What am I thinking? Sorry about that. One more exercise. It says evaluate each of the following exponential expressions involving rational exponents without the use of your calculator. Show your work, then check your final answers with the calculator. All right, so see how much you understand about this by pausing the video now and working through these 3 problems. All right, let's do it. 16 to the 3/4. Again, when it's numerical, there's no variables involved. The first thing that I'm always going to do is do the root. So I've got 16 to the 4th, 16 to the 1/4, then I'm cubing it. So that's the 4th root of 16, which is 2, and then I need to cube it, so that's 8. 16 to the 3/4 is 8. 25 to the 3/2, well, that's going to be the square root of 25 cubed, right? So this indicates a square root, this indicates a cubing. The square root of 25 is 5, 5 cubed is 125. Finally, 8 to the negative 2/3. Again, like before, what I first want to do is deal with that negative exponent. That'll be 1 divided by 8 to the 2/3. Then I'm going to deal with the root first. That's the cubed root of 8 that I then square. The cubed root of 8 is 2. 2 squared is 4. So I get 1/4. All right. Now that, I'm fairly certain, is the last exercise. So pause the video now and copy down what you need to. All right. So in this lesson, we really did look at something quite new and quite different, and that's the idea of a fractional exponent. What does it mean to raise a number to the 1/2, to the 1/3? Then by extension, what does it mean to raise it to things like the 4/5, to the 7/2, etc.? It can be tricky, and we're going to work with it a lot throughout the course. And of course, as you move on to pre-calculus next year, hopefully, you'll be working with fractional exponents a lot too. For now, though, I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.